what we want to do. So let's check what getline does. Man 3 getline. Why do we have man 3 getline? Are there other getlines? Let me do man getline. So it's still 3 that brings us to. Okay. So we are seeing two functions. Number one, get line. Number two, get the limb. So which stands for delimited string input. So to use it, we include standard io.h, and this is the format. So number one is it returns a size t. It returns a size t or an s size t, an s size t, and then the get line. The function takes in two parameters, or sorry, three parameters. Number one parameter is the line, that's the line pointer. So it takes in a line pointer. So we can see that this is a pointer to a pointer. So it takes in a pointer to a pointer. So this line pointer is actually it's a buffer, or it's an array of string. It's an array of characters. It's a string where you want to store what you are going to read from. And then the next thing is it takes in a size t of n. N should stand for the number of characters that you want to read from the screen, and then that you want to read from the file. Then it takes in a file stream. So remember that a file stream is any file that you have opened and is available to your process. A file stream that is any file that is opened and is available to your process, to the process you want to, to the process that your file, or how do I put it, to a running instance. Let me put it like that. So the file stream that is usually open for every process initially are what? The standard input, the standard output, and the standard error. So for example, maybe I open another file using fopen. I will get a new file stream. So the file stream starts with it's actually a type called file. It's a type called file, and then it's the pointer to a file type, and the file type is actually a structure. So it's a structure that contains so many information about a file that you have opened. So just for you to know that it's a structure that contains several information about a file you have opened. What is inside the file type may vary from system to system, but it contains necessary information about a file that you have opened. That is what the file type is a structure. So in this case, we have a pointer to a structure of file to a structure of file. So moving on, the other type is get the limb. What the difference is just that you are going to there is a delimiter. So this function right now is not of any use to us. What we want to concentrate on is this. What we want to concentrate on is the getline function. Okay, moving on. So the description. So it reads an entire line from the stream, storing the address of the buffer containing the text into a line pointer. So the buffer is null terminated and includes a new line character. So please take note of these two things. It is null terminated and it includes a new line character. It is not terminated and it includes a new line character if one was found. So the new line character will be included if one was found. So that means, for example, if you say read um if you say read 50 characters, if you set the size to be 50 and you don't read up to it doesn't read up to how do I put it? You don't put a new line before it encounters 50. A new line will not be there. That is just what that is explaining to you. So if the line pointer is set to null, this is another important information. If the line pointer is set to null, that means you've not assigned, it doesn't have any memory, it's not taking any space in your memory, it's just a null pointer. And n is set to 0 before the call. Then the get line will allocate a buffer for storing the line, and the buffer should be freed by the user program, even if get line failed. So the user should be the buffer should be freed by the user program even if get line failed. So that means when you are using get line, you must also be thinking of garbage collection. You must be thinking of free. Alternatively, before calling get line, line pointer can contain a pointer to a malloc allocated buffer of n bytes in size. If the buffer is not large enough to hold the line, Getline resizes it with realloc, updating line pointer and n as necessary. So that means if you put a dynamically if line pointer points to a dynamically allocated space of memory, remember you can create an array. For example, I can say char and then I put the angle brackets and I put 50 inside. That is it's automatically allocated. It means that it cannot change. So if you include that, if you put that in Getline, if you use that as your buffer in Getline, Getline can only give you 50 characters. Or what am I saying? It can only give you 49 characters because the last character must be the null byte. But if you set a pointer and you allocated space with malloc and you set that space as 50 bytes, you say allocate 50 bytes to this. By the time you put it in Getline will know that this was created with malloc, and then if the line is going to be over 50 characters, Getline will resize your buffer or the line pointer you put. It will resize it for you, and then it will return it back for you with a new size, and then it will also change this size n that you inputted. For example, if you put 50 before as n and then you got 100 characters, it will increase n also for you. So you're able to know that, okay, maybe you got 100. Initially, you set it to 50, but you got 100. So it will resize that line pointer. It will resize it to 50 and to 100 bytes, and then it will return 100 for you. So what to note, if line pointer was null initially, Getline would run malloc. If your line pointer was declared as an array and it already has a limited size, Getline will only give you the limited size. So it will only give you -1 minus ones, the size of that thing minus one characters, because the last one must be not terminated, so if you set that, okay, this can only take 50 characters, it will give you 49 characters, and then the 50th character will now be a null byte. But if you say, okay, um this will not be not terminated, I'm sorry, that's the wrong choice. If you say, I'm going to allocate memory, maybe you've already allocated 50 bytes with malloc, you set it as a pointer and you allocated 50 bytes of memory to it, then Getline is going to use that and say, okay, if this is more than 50 bytes, let me call realloc and reallocate space to contain what I want, and then to return it back to you. So because Getline uses malloc and realloc, that is why you have to free at the end of the day. You have to free it at the end of the day in your program. If you don't free it, you are going to have a memory leak. If you don't free it, you would have a memory leak. That is why you have to free it. So in either case, on a successful call, line pointer and end will be updated to reflect the buffer address and reallocate size respectively. Get delim works the same way. You can read about get delim on your own, but we don't need it right now. So let's see the return value. So on success, Getline and getDelim return the number of characters read, including the delimiter character, but not including the terminating null byte. So this value can be used to handle embedded null bytes in the line read. Both functions return -1 on failure to read a line, including end of file condition. So the end of file condition is when, if you put an end of file condition, is when you type Control D. If you type Control D when you are reading from standard input, you indicate an end of file condition. So Control D is an end of file condition. So in the event of an error, the error number is set in this case. So for now, we've not been using error numbers, but there's a way you can access error numbers. Error number is set in this case. So that is basically what we need to get. I think this is an example of, this is an example of usage. So here they are trying to use Getline to read from a file. So remember, it's not necessarily that you can use Getline to read from other things. You don't necessarily have to use it to read from standard input alone. You can open a file and use Getline to read line by line from that file. So let's go to the exercise. Any questions on Getline so far, please? Guys, any questions on Getline? Hello? Hello, guys. So are you guys there?
None from my end.
Okay. All right. I just needed the feedback. So the task says read line. And so here they have a program. Maybe we'll call our own program too, prompt. And then when you type cat prompt.c, so they want you to also print back cat prompt.c. So that's what the program is going to do. So let's write a similar program like that. So you can open your terminal and try to write also. You can open your terminal and try to write. This is how we learn. Please open your terminal. Try to do this. So remember when we did man Getline, what we need is the standard IO. We need to include the standard IO. So include std io.h int main. So they want us to, the task says, so it prints dollar sign. So that's a prompt. So it prints this, and then it waits for the user to enter a command. So we have printf. So you can print this in any way. You can use put char. In fact, let me not use put printf. So you can use put char. So we'll first do this. And remember, guys, when you are writing your own shell program, you're not going to be allowed to use printf. You're not going to be allowed to use put char. You would create your own and use. Please take notes. There's a list of allowed functions. Printf is not part of it. Putchar is not part of the allowed functions. So if you use any function that is not part of the allowed functions, you would actually it will be flagged. It will be a requirement error. So please, while you are making your own program, you must keep account, take note of that. And you're not going to use this putchar. You're not going to use printf. You're not going to use puts. You will design your own. Yes, you can use your own putchar you can use your own putchar from the previous project. You can use the string length checker from the previous project. You can use all the functions that you designed yourself personally. So this will print our prompt. So the next thing is they're saying that you should wait for the user to return something for us. So for us to use Getline, let me open that man page again. Man, Getline. So Getline. So for us to use Getline, the first thing is we need the line pointer. So we need a line pointer. So that line pointer, we can call it, I'm going to call it line. So because I don't know the number of characters the person may want to enter. But okay, let me first type. Let me first do it. So I don't know the number of characters the person may want to enter. So let me initialize this to null. So equals to null. And then it's going to take a size tn. So size Tn. I also set it to be equal to 0. Remember, this is why I'm doing that. This is why I'm doing that. If line pointer is set to null and n is set to 0 before the call, then getline, sorry, where am I here? Getline will allocate a buffer for storing the line. This buffer should be freed by the user program even if getline failed. So that's why I'm using so I'm setting it to null and size t to 0. So now, because getline returns something, right? Getline returns -1 if it fails, or it returns the number of characters. So I can do something like this. I can say what it returns. Let's see again. Let's see the prototype. So the return value is s size t. So I'll call s size t, and then I'll call it f. I will say equals to getline. So I call the function here, and then what I'm passing our line pointer. So you are passing the address. Remember, you are passing the address of the line pointer. So this address of line, our size tn now is 0. And then our file string, we want to print from standard input, abi std in. So the next thing is they're asking us to print okay, let me put it. If so, we have a condition here. If f equals to -1, remember, if it fails, let's see the return value. So both functions return -1 on failure. So on failure to read the line, including the end of file condition. So when we also encounter the end of file condition, you get f1. So if f is equal to f1, you can, let's do something here. Let's do printf.
The equal to is only one. Used one equal to.
Sorry, that was my error too before.
Yes.
So printf so this is a fail. I mean, there is a failure. Let me put it this way. There is a failure or the end of line encountered. Sorry, end of file. There's a failure or end of file encountered. So if not, we want to print the entire line. Puts. Let me not use puts. Let me use printf. The reason why I'm not using puts, remember, puts will print a new line automatically at the end of everything is printing. That's why I'm not printing using puts. So I can do printf. It's an s. I don't need to include a new line. The reason why I don't need to include a new line is because I'm reading from a line, right? And the end of a line is always the new line character. So by the time I've read from the line, the new line character will automatically be there. So if I'm including a new line again inside here, then I'm going to have two new lines printed. Do you understand? Because I'll return. Okay, let me do another printf here. Printf, I will say, I want to see how many characters were printed. So percent %d. This one I have to include a new line. Then size tn. So this get line is supposed to update the value of size tn. I think I'm making a mistake. Do you know the mistake I'm making? There is a mistake in this code I've written. Number one, I implicitly set 0 here, which is wrong. Then number two, it's supposed to be the address of n. The reason why you are passing the address of n is because you have to pass it by reference so that the program can adjust the value in memory. That is why you are passing it by reference. So we can now say return here. Return there. So you can test it out. So we have our prompt.c. So let's run it. Okay. Okay. So size C is a long unsigned thing. So I need to go and change that. So we use LDB. So no error. So now we run our program. So can you appreciate this now? So you can see it's waiting for the user to input something. So the test here, they use cat prompt. So let's type cat prompt C inside there. So we'll do cat prompt dot C. Okay. So you see it printed out cat prompt dot C. And then it printed 120. Why did it print out 120?
It seems that's hard coded because if you try something else too, it's still giving us 122.
Okay, so you've tried this before and it keeps giving you 120.
No, like I'm following along.
Okay. So why is it giving us 120? So n size t of n. We passed in the address of n. So printf as the line, okay. OUN. Let me try this again. Okay. I'm going to do something now. I think
Okay, sorry. I think I found it. From the man, if you look at the example where they used where they try to print out the length, what they use as the length is actually the
return value, Abi.
exactly.
Why is it printing 120? Why do you think it's printing 120? You see all the things I'm typing. I want to show us something. I understand
So
what is
break the
going on.
120.
I want to break the 120. I believe it should be more than 120,
But
right?
I don't think it will break.
It has broken.
Oh man.
675. So for you, if you want to design your own Getline, what this is proving to you is that Getline uses a buffer system. Getline uses a
Set
buffer system.
different.
So initially the buffer is set to 120. When you have reached the limit of the buffer, it will increase the buffer and call realloc and reallocate more space. Do you understand? Once you go beyond that buffer again, it will call realloc and reallocate more space to that buffer. So it is now at the end of the day, it is that buffer that it returns to you. Do you understand? So it's not always going to be calling realloc. It's not always going to be calling it's not always going to be calling realloc every time you are typing. So it will make sure it first creates a particular amount of space for you to use. If what you used is not up to that amount, it will not call realloc again within itself. But once you have gone beyond that, it will call realloc and increase the buffer size. So it keeps on increasing the buffer size for you so that it can function. I don't know if you understand that.
Yes, yes, too.
Yes, of course.
So if we set this, if we change our code and print F instead. So if we come back here, we do this. So we do hello world. So it's still returning. Oh, sorry, I didn't recompile. So I do hello. So now you see we're having 12. Why is it 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then the new line character makes it 12. Do we understand?
Yes, sir.
Okay, so one thing I want to test out is what if we say, okay, this guy should be an array of 50. Or let me say an array of 10. Let's use something so that we don't keep typing. And then we set this guy to 10 here. No, we can only set this guy to 9. And then here, we put the address of M there. Okay. So what if we do it like this? This is one of the things you can do just to learn. The way we did it before is the right way to do it. So, but one of the things I like to do is, what if I do it in another way that is not the conventional? What result would it give me? Do you understand? That is how me I do my things. What if I do it in another? What result? What would happen? So let's see what will happen if we do it like that. So the first thing is that it is giving us an error. So that means we can't do that. Remember, we cannot compile like this. So it is giving us an error. So warning, passing argument 1 of getLine from incompatible pointer type. Expression star star. So we're not supposed to call it as an array. Do we understand? So we are not supposed to call it as an array. So, but the argument is of type char 10. So we're not supposed to call it as an array. So that means this is going to give us a problem. So that means we cannot do this. If you do this, you will get an error. You see, we get a segmentation fault. The reason why we get a segmentation fault is that when we passed it like that, you cannot call realloc on that. You cannot, so getChar cannot work with, getLine cannot work with it. So that's why there is a problem. So that means we cannot use this. That means we cannot do this for our program. We cannot set a buffer size as an empty array. So that means this is not going to work. So the best way for us to do it is this. So even if we do it like this, you see that we have set line now. Let's say we set line equals to null. Let's go back. So what if we keep this as 9? What if we keep size t as 9? What happens? Let's see what happens if we keep size t as 9. So let's recompile. Okay, I think I didn't. Somewhere I didn't terminate a statement here. So remember we have put 9 there. I want to type something more than 9. So we know hello world is more than 9. So you can see that it has resized it for us. Or it ignored the size and still went ahead. So let's see another use case.
Sorry, I tried something kind of like a tricky-ish kind of thing,
Okay.
where because we're saying arrays, so I kind of like redefined. I set an array still, but I now set a pointer to point to the array, right? Um, that's a pointer equal to the value of the array, or a pointer points to the array, whatever it is, and then I use the pointer um the pointer name, right? And he actually passed. Okay, let me just share
Share your
what I.
screen. Share your
Okay, let
screen.
me. Okay. Uh, Hope it's not going to take you out.
Don't worry, just share your screen.
Okay. Let me- Yeah. Okay. Can you see my screen?
Yes.
Okay. Yeah. So I did this, right? And then I did this. So created a pointer that that was pointing to this, more or less. Does this
Okay.
work? Does this make sense? Does this work? Does this point?
Okay.
yeah, so when I did this, right, and I ran it, it ran like it didn't give any errors. But when I tried to run it, it is running fine until I tried to put in something, and then bam, dialog. So again, I think it's very important that we use pointers because dealing with malloc and realloc within the get line, it will always affect if we don't use pointers directly.
Yes. So here now, Realog cannot it cannot, because when you set that array, when
Yeah,
that array you did, it was it was automatically assigned.
yeah, yeah.
You understand? So it was automatically assigned. The memory space was already that block was automatically assigned. So you cannot edit it.
They are
You
lucky. Yeah,
cannot change
yeah.
it. So Getline cannot reallocate to it.
That's
So
yeah.
that's the problem.
Yes.
So I think we've been able to know that we shouldn't do that.
Yeah.
We shouldn't do that. Thank you so much.
Thank you, Ross.
So my screen is still on. Can you
Yes,
guys see?
yes.
Yeah. So, so if we do what was it I wanted to do? Okay. So what I wanted to do is I wanted to do malloc. There's something we have been leaving out in this function, guys. Remember, we're supposed to free at the end. So before returning, please always make sure you free. So free line at the end of the program. But here, let's say I do so I want to do line equals malloc of size of char times n. So we have a space already. Remember, we have to do our if not. So if this is no, if line does not return anything, so we can return from the program. Ah, okay, I didn't declare. Sorry, I thought I have standard lib. Okay, not in this one. So remember now, what we are testing is the fact that we have called malloc. We have used malloc to allocate space initially. So let's do this now. So initially we allocated space for 9 characters. So let's do hello world. So it's still printed because it has called realloc. Do we understand?
Yeah, yeah.
Okay. So I think that's about it for Getline. So let me see. Let's just take a short time, and I want us to take a break. So let's do the second part. So the second part now says write a function that splits a string and returns an array of each word of the string. So it splits a string and returns an array of each word of the string. So what are we? We're supposed to check man str talk. So advanced, write a function, write the function without str talk. So that's the advanced one. So let's understand what str talk does. So str talk is actually string token. So where you tokenize a string. So remember what a token is. Everything that you are imputing into your program is a token. Every word, every representation of everything you can read from your program is a token. Let me do this prompt again. So here, put char is a token. This open bracket, close bracket is a token. This that is inside, this is a token. This is a token. Do you understand? Because all of them have different meanings. Null here is a token. Equal to, this equal sign is a token. So everything, every group of characters inside your C program or inside any of your program that has a meaning to the program is a token. Semicolon is a token. This semicolon is a token. Why? Because it indicates the end of the statement. Do you understand? So our goal is to, let's go through the string token. So let's do man. Okay, so str talk or str talk r. So it extracts tokens from strings. It extracts tokens from strings. So for you to use it, you have to include string.h, and then you have to do char. So this thing is the prototype. So it returns a char. It returns an array of characters. I mean, so it returns a string. So straight talk. So the input is it takes in a string, and then it takes in a delimiter. So you have to note that it takes in a string, it takes in a delimiter. So it has a sister function which we are not going to use. We don't have any business with the sister function. So I think you can read that on your own. So the strtok function breaks a string into a sequence of 0 or more non-empty tokens. So on the first call to the function, the string to be passed should be specified in this in str, and then in subsequent calls, in subsequent calls, in each subsequent call that should pass the same string, the str must be null. So that means you don't have to include it again, but instead you call null. Now, one of the things that you need to note here is that it takes in the string, and then the delimiter too is also a string, not a character. So don't make that mistake. Delimiter too is also a string and not a character. So the delimiter argument specifies a set of bytes that delimits the token in the pass string the caller may specify different strings in the limb in successive calls that pass the same string. So that means you can have more than one delimiter string. So depending on what next you want to get, you can change your delimiter string. Okay, so let's continue reading. All right, so each call to the function returns a pointer to a null terminated string containing the next token. So this string does not include the delimiting character. So if no more tokens are found, then the function will return null. So a sequence of calls to the SAR talk that operate on the same string maintains a pointer that determines the point from which to start searching for the next token. The first call to SAR talk sets this pointer to the point to which the first to point to the first byte of the string, and then the start of the next token is determined by scanning forward for the next non-delimiter byte. And for the next non-delimiter byte in STR, if such a byte is found, it is taken as the start of the next token. So if no such byte is found, then there are no more tokens, and STR talk will return null. So a string that is empty or that contains only delimiters will thus cause STR talk to return null on the first call. So the end of each token is found by scanning forward until either the next delimiter byte is found or until the terminating null byte is encountered. So if a delimiter byte is found, it is overwritten with a null byte. Now that is where you are going to understand how this works. If a delimiter byte is found, it is overwritten. So number one thing is that the STR talk will affect whatever string you pass into it. So we need to understand that it will edit that string, it will change that string, it will break the string. It will break the string. So anytime you want to use the STR talk, if you still need the string you are passing into it, you should duplicate it. So just for something, that's something you need to note. If not, when you are using it and you try to call that same string, you would have an error in your program. Okay, so from the above description, it follows a sequence of two or more contiguous delimiter bytes in the pass string, and is considered to be a single delimiter. And that delimiter bytes at the start or end of the string are ignored. Put another way, the tokens returned by STR talk are always non-empty strings. Thus, for example, given the string AAA ... successful calls to STR talk that specifies the delimiter, that delimiter string this and this would return AAA and BBB, and then a null pointer. So that means with this, if you use this as your delimiter, then it will separate this, it will remove this to give you this, and then give you this. So it will also remove the full stop for you. So the STR talk function, okay, this is sister function. We don't have anything to do with that. So what are the return values? We already know that it returns null if it has gotten, if there is no more, if it's only delimiters, or if it has gotten to the end of the string, or it returns the string that it's breaking off from your string. So you can go through this again on your own so that you can understand it more. But let's have a program that would help us to understand what we are doing. So let me use this for our manual page. So let's create a program. The program would be strtalk.c. So the first thing is that we have to include our header file. So our header file, sorry, let me minimize this. So the header file to include, remember you need to include string.h. So string. So guys, we can also follow along. String.h. And then let's call our program int main. So let's declare a string. Our string would be, now guys, please note this. If you do this, if you do this, you cannot edit this string. This is a string literal. You declare a string literal. It's a constant, and you cannot edit it. If you don't understand string literals and or string constants, I think you should read on it. This is not going to work. This is uneditable. I repeat, this is uneditable. Do we understand? This is uneditable. Another thing you can do is do this. So you can have something like this. This is not a string literal. This is not a string literal. So this, you can edit this. So I want to call start talk. So we know that this one has 2 words. So let me define my delimiter as so let me call it delim. So our delimiter is going to be, in this situation, our delimiter will be this with, remember it's a string. So our delimiter will just be space in this situation. Or let me do it this way so that for better understanding of this thing. So let me put a full stop here. So, but I don't want the full stop in my program. So I'll put space and full stop. So I can call this twice. I can say char I can say star let me do string 1 str1 equals to, so I'll call start talk and I'll first pass our str, and then I'll call the next thing is our delim, and then I will now call our, what else? I think it's just 2 things. Sorry, yes, it's just taking 2 things. I'm not calling any other thing. So this is the first time. Remember, this is the first time I'm using it, right? So I can now say char star 2 str2 string 2 equals str talk. So this time around, instead of passing str, because I'm still working on the same string, I will pass null and the lim. So let's see. So let me come back here and add, let me include our stdio. So include stdio.h. So let me just use puts str1. So let me do it this way. So what I want to do is I want to try again to see if we can print our original string from the beginning. So I think everything looks good, Abby. There's something is off here. This what happened to my initial? What happened to string 1? And my delimiter 2 got deleted. What happened? Okay, so everything is correct now. So let's what happened? Guys, this was the error here.
You have a closing tag after void.
This is the problem. No, it's not the code. This is the problem. I'm going to put an end of this thing there. So it compiles well. Okay. So you can see ah is this an okay at all? This is supposed to be the reason why this is getting affected. This got printed wrongly is that I shouldn't print it there. I should print it before we started manipulating the string. Do you understand? So let me just put something here. So we'll first print the string hello world, this one, before we call str talk. So we will print the first part of the string. We'll print the second part after we have gotten them out by str talk. Then we'll now see what will happen, what will be the final version of the string of this str after we have called str talk. Do you understand? So that's the program that's what this program is. Let's see, let's run it. Okay, what happened again? Format, not a string literal. Okay. What's going on here now? 9:14. Too many arguments. Okay. Oh, sorry. Finally. So, the initial string before calling str talk, you can see it, hello world. The first part gotten by str talk, hello. So we've been able to separate this. The second part, world, been able to separate this. So now, the initial string, what happened to the initial string after we called hello this thing now? It's now saying that it is world. So that means it broke this one out. Why? Guys, why is this happening? Hello guys, are we here? Why is it that the initial string changed? Guys, feedback please.
It has broken the string, I guess.
It has broken the string.
And so like that's the only value left in that string, sort of.
Okay, very good. Now let's understand this. Let me expand this. Let's see what it said here. I think this is why this. I think this is information. If please read this that I'm highlighting. If a delimiter byte is found, it is overwritten with a null byte to terminate the current token. So this string talk, it overwrites, number one, it overwrites the initial string. So that is why if you still need that string, you should copy it. You should make sure you duplicate it somewhere. And either you work with that copy. Do you understand? If you are still going to use that string, you would need to duplicate it. Because if a delimiter byte is found, what it does is it overwrites it with a null character. And remember, what is a string? A string is a group of characters, right? It's an array of characters that end with a null byte. So what happens here is that by the time printf starts printing, printf will start from the beginning, HELLO. So because this space has been replaced by a null byte, so it terminates there. So it will now just be hello. So it will change this, and then the world part of it, is lost. Do we understand? Hello guys, do we understand? Yes, please. Mr. Shegun, please, you can go ahead, please talk.
No, it was a mistake. It was a mistake, sorry.
Okay. All right, do we understand?
Yes.
Okay. So it's because of that replacement that you have this printing hello. So basically, I think we can take a break here. Please, if you have questions, you can ask, we can discuss. The plan is actually to keep this group open. So I may not be around, but so long as people keep joining, we can just keep on help. You can just put we can put each other through. That's just the basics of it. Um so I think we've done this. So the next thing is I think we can go and let's have a redo. You can go back to the beginning, try to work with PID, PPID. Just try to do something on your own. That's not necessarily what is in the assignment. In the exercises, try to do something on your own. Try to manipulate a string. Try to print out parent processes. Try to handle different things on your own. Do you understand? Try so that you understand. Just basically, you want to understand this concept before you dive deep into your shell. Then we could learn. Maybe we could start talking about this, but I think I'm taking a break now because I'll need to go to work. I'll need to do something. So maybe somebody else can take us on this. Somebody else can discuss the exec v function. Somebody else can share your screen and go on it. Is that okay?